ఎవలెయ్యొద్దనిక అన్నీ వస్తుందని.
హ్మ్.
ఆ! Okay, good evening, friends. Are you there? Whether I am audible for everyone? Okay, thank you. Sorry for the delay. Power emotion. 3 times I have done login, 3 times suddenly power is gone. Okay, let us start the concepts. Yesterday, we started Fourier transform topic. Fourier transform. The definition of Fourier transform we selected as capital X of omega equals to integral x of t e power minus j omega t dt. Whereas the inverse Fourier is 1 over 2 pi integral of x omega e power j omega t d omega. That is inverse. We named exponential term as kernel or basis function. The meaning of kernel is the frequency components of the signal are controlled by this exponential. And one more observation we have made is we have chance of representing in F symbol also. Externally omega is there means our replacement is 2 pi f. One more change, 2 pi del omega is equivalent to del of. The last model which we consider is spectrum at zero. Spectrum at zero means what is happening to the right side quantity, sir? Area under the signal. When we replace omega place 0, it becomes area under the signal. What is signal at 0 means? It becomes area under the spectrum. Small x0 means area under the spectrum. Okay. Area under one domain corresponds to observing the other domain at origin. Area under one domain corresponds to observing the other domain at origin. That is what we discussed. Even the convergence of Fourier transform also we studied, where we studied 3 different points. Fourier transform is defined for stable and energy signals. Fourier transform of power signals is defined as approximation to energy signals or impulse functions are permitted in the spectrum, whereas it is not defined for neither absolutely integrable nor square integrable signals. There we have given examples like ramp and growing exponential. So integral mod xt dt less than infinity is a sufficient condition, which is not a compulsory condition. Okay. Let us discuss Fourier transform of certain standard signals. Listen carefully the topic. Let us discuss Fourier transform of certain standard signals. Suppose we selected e power minus at ut. We know it is a decaying exponential. E power minus at, it is a decaying. What is the Fourier transform for this signal? Now only class started. Don't be tensed. Those who have joined just now, don't be tensed. Now only the class started. Just we have made a recap in the first slide. Definitions, whatever we have learned yesterday. Okay. So when you try to take decaying exponential, which is there for a positive time, what is the range of integration to be where it's at? 0 to infinity or not? 0 to infinity. Integral 0 to infinity e power minus at multiplied by e power minus j omega t dt. Signal multiplied by, further it is taken as 0 to infinity e power minus of a plus j omega into t. So it is simplified as what's that? E power minus a plus j omega into t by minus a plus j omega over the limits 0 to T place infinity means e power minus infinity 0. Substitute t place infinity. T place 0 means, so what is the new answer? 1 by a plus j omega. So decaying exponential is a transform pair with this two-side arrow, meaning is transform pair with 1 by a plus j omega. It is actually called as Fourier transform pair, sir. Two-side arrow meaning is Fourier transform. Fourier transform pair meaning is we have one-to-one correspondence between time domain and frequency domain. Every one of you know decaying exponential is which signal? An energy signal or not? Decaying exponential is an energy signal. So Fourier transform of that function is defined 1 by a plus j omega. What is the meaning of one-to-one correspondence is whenever this is the signal, respective spectrum is 1 by a plus j omega. Whenever this is the spectrum 1 by a plus j omega, the respective signal is decaying exponential. E power minus at ut transform pair with 1 by a plus j omega. 1 by a plus, that is called as Fourier transform pair. Fourier transform pair. We have one-to-one correspondence between time domain and frequency domain. We have one-to-one correspondence between time domain and frequency domain. You also say with me the relations which we are deriving today. You also say with me, you must habituate to that formulas, otherwise it will be very difficult. Either you are EC or instrumentation, sir. Be thorough with the relations. Tell me everyone, what is the Fourier transform for decaying exponential, sir? What is the Fourier transform for decaying exponential? 1 by a plus j omega. 1 by, whenever the spectrum is 1 by a plus j omega, whenever the spectrum is 1 by a plus j omega, then what is the respective signal? Whenever the spectrum is 1 by a plus j omega, what is the respective signal? E power minus at. Let us try to draw the shape of magnitude and phase spectrum. What is magnitude of this quantity? Come on. What is the magnitude of this quantity, sir? 1 by root a square plus omega square. 1 by a plus omega magnitude is 1 by root a square plus omega square. Let us verify for various frequencies. Let us verify for various frequencies how we are going to retain the shape of magnitude and phase angle. How we are going to retain the shape of magnitude and, as the other term is a square, I am assuming omega as multiples of a, sir. Other term is a square, I am assuming omega as multiples of a. Respond everyone. If I take omega 0, what is the magnitude level? See here, see the cursor. If I take omega 0, magnitude is 1 by a. If I substitute omega place plus or minus say, it is 1 by root 2 a square or not? 1 by root 2 a square means 1 by a root 2. 1 by omega plus or minus 2a means here 4a square plus a square means 1 by a root 5. It is a rough graph, sir. At plus or minus infinity, it is tending to 0 or not. When you combine all those points, roughly it is forming the shape of the curve like this. It is a rough graph, as we are not taking any graph paper. Roughly that is the shape of the curve. Roughly that is the shape of the curve. That is the shape of magnitude spectrum, roughly Gaussian type. It is looking like Gaussian spectrum. Okay. What is the phase angle? You should respond, sir. What is the phase angle? 1 by a plus j omega. 1 by a plus j omega means what is the phase angle? Minus tan inverse of omega by a. Minus tan inverse of omega by a. Let us try to observe. Let us try to observe for the same frequency points. Let us observe for the same frequency points. Omega 0 means tan inverse 0 by a 0. Omega value A means A must be positive. In the beginning only, we have made that assumption. A must be positive. Tan inverse A by A means tan inverse 1. That becomes how much? Pi by 4 with negative sign. Substitute omega place A, sir. Tan inverse A by A minus tan inverse 1 means minus 8 becomes what? Plus pi by 4. Minus 8 becomes omega 2A means around 63 tan inverse 2. Like that, the highest frequency that is possible is plus or minus infinity, where it is approaching to plus or minus 90 degrees. If you take omega as plus infinity and minus infinity, it is approaching to plus or minus 90 degrees. So everyone tell me, magnitude spectrum is even symmetric, phase spectrum is odd symmetric. Combinedly we call that as which symmetry, sir? Respond. Magnitude is even, phase is odd. Even in Fourier series also we have studied that. Even Fourier series also we have studied that. Don't get emotion, brother. Everywhere you cannot replace j omega as s. Don't be tensed. Certain signals, Fourier transform will be there, Laplace will not be there. Don't get emotion. Let me discuss. With half knowledge, don't get emotion. Let me discuss the points. Okay? There are certain signals for which Fourier transform will be there, Laplace is not there. Vice versa also. Other way also. Don't get emotion. So decaying exponential, Fourier transform is 1 by A plus j omega. Magnitude is even symmetric, phase is odd symmetric. Combinedly we call that as conjugate symmetry. Combinedly we call that as conjugate. So the Fourier transform of a real signal or real valued signal. Real valued means if you see this decaying exponential, at any instant of time the amplitude is a real number. If you see this decaying exponential, at any instant of time amplitude is a real number. It is exhibiting with symmetry. Conjugate symmetry. Magnitude is even symmetric. Phase is odd symmetric. Magnitude is even symmetric. Phase is odd symmetric. Very good. Conjugate symmetry. Conjugate symmetry indirect meaning is what, sir? Some fellows will use the word conjugate even. That is also correct. Conjugate even. What is the indirect meaning of this word conjugate symmetry? Magnitude is even, phase is odd symmetry. We have done the mathematics, that is okay. But what is the physical aspect we should understand here is, listen everyone, maybe decaying exponential is physically generated due to a simple RC circuit. A simple RC circuit, practical. Capacitor impedance is what? 1 by j omega c or not? 1 by, if I apply voltage division principle, 1 by 1 plus j omega RC is the answer. Solve for its frequency response by applying voltage division principle. If you take RC common, the answer becomes what? J omega plus 1 by, which is looking like our formula or not? See the cursor, 1 by A plus j omega pharma. What is the meaning of A? 1 by RC. So in a practical case, how to adjust RC component such that within the low frequency, we will get peak energy level. What we proved yesterday under Parseval's theorem. Maximum energy or power must be there in which region, sir? Low frequency region. If you want to obey that condition, what is RC components we have to take? Practical case. Signals and system we are doing mathematical enjoyment only. No signal, get the spectrum. Okay. Sketching magnitude and phase spectrum is Bode plot, asymptotic plot you are sketching, Bode plot. How to generate the signals? Physical form is analog circuits. So if you think in a proper manner, engineering is one subject only. If you know the signal, how to get spectrum is signals. Sketching magnitude and phase spectrum is Bode or Nyquist plots. Bode plot or like how we are physically generating a signal, that is what we are learning in analog subject. Suppose we are discussing rectangle Fourier transform, sir. Suppose we are discussing rectangle Fourier transform. Rectangle may be generated due to a multivibrator. Rectangle may be generated due to a multivibrator. So what is the meaning of this term real valued? At any instant of time, the amplitude of the signal is real number. See the cursor. At any instant of time, the amplitude of the signal is real. That is what real valued signal. Everyone say with me. Decaying exponential Fourier transform is what? 1 by a plus j omega. Decaying exponential Fourier transform is 1 by a plus j omega. That is the first signal we have. Decaying exponential. Second signal is an increasing exponential e power at u minus t. It is called as increasing or growing exponential. Increasing or growing. As it is multiplied by u minus t, it covers only what types are? As it is multiplied by u of minus t, it covers only which time? Negative time. As it is multiplied by u of minus t, it is covering only negative time or not? Tell me. So it is called as increasing or growing exponential. Increasing or growing exponential. Now you tell me how to get Fourier transform of this signal. How to get Fourier transform of this signal? Are anonymous, please keep quiet. Don't do unnecessary overaction. Okay? To whom you are sending that message? If you have PC problems, contact me. First you see about your problem. Don't irritate. Okay? Listen the class. Isko bhej rahe aap? Okay. What is the relation between first signal and second signal? First signal is decaying. Second signal is growing. The folded version of first signal is looking like second signal or not? Everyone see here, sir. Just take folded version of x1t. Reversal. Folded version of first signal is looking like second signal. So we can say x2 of t as x1 of minus t. We can say x2 of t as x1 of. So here we can apply time reversal property. What is time reversal property of Fourier transform is, if t is replaced as omega, minus t is replaced as minus omega. If t is replaced as omega, minus t is replaced as minus omega. That is reversal, sir. So what is the Fourier transform for this expression? We can write x2 of omega equals to x1 of minus omega. x2 of omega equals to x1 of. In the previous answer, omega place what we have to substitute? In the previous answer, omega place what we are substituting, sir? Minus omega. So what will be the new answer? 1 by a minus j omega. Without solving, directly reversal property. The second signal is folded version of first signal. So directly in the spectrum, omega is replaced as minus omega. Everyone tell me, sir, now which spectrum changes? Magnitude spectrum or phase spectrum? Come on. Magnitude is 1 by root a square plus omega square or not? But phase angle now becomes plus tan inverse of omega by a. You will get opposite way. Plus tan inverse of omega by the application of time reversal property. Which spectrum changes? Phase spectrum changes. By the application of time reversal property, phase spectrum changes. Magnitude remains same. Magnitude remains same. Very good. Most of you answered. Very good. Only phase spectrum changes. Magnitude spectrum remains same. First signal is decaying. Second signal is growing exponential. If we try to add this first signal and second signal, if we try to add them, sir, first signal and second signal, they are combinedly called as which signal? They are combinedly named as which signal? Come on. E power minus a mod t. E power minus a mod t. Sum of decaying and growing exponential is a double-edged exponential. Sum of decaying and growing exponential is two-sided exponential or double-edged exponential. Double-edged means both sided. Two-sided or double-edged exponential, which is sum of decaying and growing. It is looking like sum of decaying and growing or not? Tell me. It is sum of decaying and growing. Okay. So this can be directly selected as e power minus at ut added to e power at u of minus t. E power minus at ut added to e power at u of positive time decaying, sir. Negative time growing. Signals are added means what will happen to their spectrums? Come on. Signals are added means their spectrums are also added. It is like linearity principle or not? Signals are added means their spectrums are also added. Tell me. Signals are added means their spectrums are also added. Sinker. अरे ये concentrate करो रे पहले. What is the Fourier transform first term? Just now we derived 1 by a plus j omega. What is the Fourier transform second term, sir? 1 by a minus j omega. It is available. After adding them, it becomes 2a by a square plus omega square. 2a by a square plus two-sided exponential e power minus a mod t is Fourier transform pair with 2a by a square plus omega square. Two-sided exponential is Fourier transform pair with 2a by a square plus omega square. Sum of decaying and growing exponential. Sum of decaying and growing exponential. 2a by a square plus omega square. Just a minute. Yes, sir. Now it is visible or still problem is there? Is it visible now? Some of you are saying not visible. Display gone. It is visible now. Yes, so many of you are saying it is visible. Is it okay? Yes. I'm really sorry what happened in the last 2 minutes. Okay. Let me explain one more time. We have taken a two-sided exponential. I'm really sorry. Yeah. We have taken a two-sided exponential. Which is sum of decaying and growing. It is sum of decaying and growing. What is addition of the signals concept is like simple linearity for us. Addition of the signal is simple linearity. When we are adding the signals, the respective spectrums are also added. When we are adding the signals, the respective spectrums are also. First signal spectrum 1 by a plus j omega. Second signal is 1 by. Overall becomes 2a by a square plus omega square. Overall becomes 2a by a square plus omega square. Okay. Okay, I'm really sorry here. I have not observed. My emotion is going on. I'm really sorry. Okay, sorry. From this example, we should make one observation. What is that is, this two-side exponential is a real and even signal or not, sir? It is real, even signal. What about our spectrum? 2a by a square plus omega square is a real term or not? If I replace omega as minus omega, answer is same. Two-side exponential is a real and even signal. Spectrum is also what? Real and even. Don't confuse with our first statement. A real valued signal has conjugate symmetry. Just real valued means no apparent symmetry for that. A real signal can be individually even, individually odd or not. A real signal can be individually even, individually odd. So just a real signal means it exhibits conjugate symmetry. But that real signal can be separately what? Real and even. If the signal is real and even, what is spectrum nature? Real and. So a two-sided exponential is Fourier transform pair with what? 2a by a square plus omega square. 2a by a square plus omega square. What happens in this problem only if I take middle minus sign here? Everyone see the cursor, sir? Instead of plus, if I take minus sign in the middle, everyone see here, see the cursor. Instead of plus, if I take minus sign. So how you can write that expression is y2 of t equals to e power minus at ut minus e power at u of minus t. Nothing I have done. In the previous slide, middle plus sign is there. Now I have taken minus sign. Now I have taken minus. So this is a decaying exponential. E power at u minus t is an increasing exponential with a negative sign, means amplitude scaling. Normally how growing exponential is there, sir, like this. What is the meaning of minus? It will come downwards. It will come downwards. Now you tell me what is the Fourier transform answer? In our previous slide, middle minus sign. See the cursor, sir? Instead of plus, what you have to take here? Minus sign. So add the numerator terms. If you add the numerator terms, y2 of omega equals to minus 2j omega by a square plus omega square. See our previous slide, 1 by a plus j omega with middle minus sign. With middle minus sign, that is simplified as what? Minus 2j omega by a square plus omega square. What is limit a tends to 0 y2 of t? What is limit a tends to 0 y2 of t, sir? In the signal expression, if I substitute a plus 0, what is happening? Ut minus u of minus t. It is treated as which function? Everyone should respond. Ut signal added to minus u of minus t is which function, sir? Signum. So by substituting a plus 0, we converted this curvature to what? Constant amplitude of plus or minus 1. Originally they are curvatures. By substituting a plus 0, we converted curvature to what? Constant amplitude of plus or minus 1. So it is signum function or not? It is signum function. Now it is signum function. As we have done approximation in the signal, do the same approximation in its spectrum. As we have done approximation in the signal, do the same approximation in the spectrum. So what will be the answer, sir? If we substitute a plus 0, minus 2j omega by omega square, which is simply minus 2j by omega, which is simply, so signum function Fourier transform pair with 2 by j omega. Minus j I have written as 1 by j. Minus j I have written as 1 by. Signum function is Fourier transform pair with 2 by j omega. Signum function Fourier transform pair with 2 by j omega. Everyone respond. Signum function is an energy signal or power signal. Just recollect our energy power signal concept. A signal which maintains constant amplitude for infinite length is which signal? Recollect everyone, power signal or not? A signal which maintains constant amplitude for infinite length is power signal. Okay. Yesterday, what is the second statement I have given in convergence, sir? Fourier transform of power signals is defined as approximation to energy signals. Fourier transform of power signals is defined as approximation to energy signals, or they can include impulses also. That is another technique. Or they can include impulses also. They can include impulses also. So signum function is having Fourier transform 2 by j omega. Signum function is having Fourier transform 2 by j omega. Okay. So we converted the curvature to constant amplitude of plus or minus 1 means signum function by doing approximation. Fourier transform of certain power signals is defined as approximation to energy. If you want to solve signum function Fourier transform from our direct definition, you will get answer as infinity. You may get a doubt that what for we have done this approximation, sir. You may get that doubt. Because of this relation only, we got 90 degrees phase shifter, that is Hilbert transform. J will create how much phase angle for us? Plus or minus 90 degrees or not? J imaginary term. Because of this formula only, we got the thought of Hilbert transform. In few minutes, you will know that Hilbert transform. Another observation here we have to make is signum function is real and odd or not? Plus or minus 1, which is odd function. But what is spectrum? Imaginary and odd. J term is there means imaginary. When you try to draw its phase spectrum, it becomes odd function of frequency or not, sir? So real and odd becomes imaginary odd. Real and odd becomes imaginary and odd. Correct or not? Real and even is real and even. From our previous example, real and even is real and even. Real and odd becomes imaginary odd. See the previous example, two-side exponential. Real and even again becomes what? Real and even. Real and odd becomes what? Imaginary odd. Real and odd becomes imaginary. This is a most important question theoretically asked in exams. Listen carefully, sir. Listen carefully. Even odd, one side, other side also you take. Even odd means one side it is time domain, other side it is. On the lower side, interchange the blocks. Odd, even. Odd, even. How to remember this in easy manner? For that, one simple technique. Real, real. Imaginary, imaginary. One side it is a time domain, the other side it is frequency domain. One side it is TD, TD means time domain, other side FD, frequency domain. What is the first condition we checked in the previous case? Signal is real and even means spectrum is also real and even. Correct or not? Come on, sir. See our previous slide. Signal is real and even means spectrum is real and. Signal is real and odd means spectrum is what? Signal is real and odd means spectrum is what? Imaginary odd. That is what this example, vice versa. If you take imaginary odd function in time domain, it becomes real and odd. If you take imaginary odd in time domain, real and imaginary even becomes imaginary even. Still for the last case, we should give an example. Imaginary even becomes imaginary. Total 4 combinations are real. A signal can be real or a signal can be complex. Real signal is individually even and odd. Imaginary signal can be individually even and odd. Real and even again becomes real and even. Real and odd in time domain is imaginary odd, vice versa, opposite also true. Imaginary even becomes imaginary even. Still I have to give an example for this last combination. In few minutes, at a different property, I'll give example for imaginary and even function. Imaginary and even function. Just real signal means conjugate symmetry. Don't mix the words. Just real signal means conjugate symmetry. Okay. See the funny thing in the slides. First, we started with decaying exponential. By folding that, we got growing exponential. By adding decaying and growing, we got two-sided exponential. Subtraction with an approximation. We have done subtraction of the same signal with approximation. We created signal. Till now, we discussed 4 formulas, but all 4 formulas are depending on which relation? Our first relation. That logic you should know, sir. Whatever the 4 relations we have derived, they are all linked to first signal or not. Decaying exponential is Fourier transform pair with 1 by a plus j omega. Decaying exponential is Fourier transform pair with 1 by a plus j omega. Correct or not? Decaying exponential Fourier transform pair with 1 by a plus j omega. Everyone, repeat with me. Close your eyes for a few minutes. Don't sleep. Real and even again becomes what, sir? Real and even. Real and odd becomes what? Imaginary odd, and vice versa. Imaginary even becomes which function? When you take imaginary and even function, answer is imaginary and even. Imaginary even becomes imaginary and even. One funny question that was asked in one of the exam for ISRO, this examiner, this is a favorite question, sir. Why it is favorite? 4 options are neatly available. If the signal is real and even, what is the spectrum nature? He can create 4 options or not neatly. Tell me. In one of the exam, the question is asked like this. A function f of t is taken like this. What is the nature of its spectrum? Theoretical question, sir. This is the function graph given. What is the nature of the spectrum? You can use our previous slide hint. You decide the nature of the signal in time domain. TD means time domain, FD means frequency domain. This given graph is satisfying which behavior? Amplitude plus or minus 1 means real. Amplitude plus or minus 1 is real. It is looking like even function or odd function. It is looking like even function or odd function, sir. Odd. Okay. So, if the signal is real and odd, as the signal is real and odd, what is the nature of the spectrum, sir? Imaginary and odd. If the signal is real and odd, what is the nature of the spectrum? Imaginary and odd. Correct or not? Signal is real and odd means spectrum is imaginary and first you find out the nature of the function. Odd signal, don't eat my brain. F of t is minus f of minus t. Take folded version with amplitude scaling 100%, it is odd. Okay. So if the signal is real and odd, spectrum is imaginary and odd. Okay. So you must be thorough with which point? This previous slide or not? Signal real and even. Spectrum is real and even. Real and even. Which example I have given? Two-side exponential example. Two-side exponential is a real signal, which is folded version is again same. The spectrum is also real, folded version. Omega plus minus omega means answer is same. Next, we have taken example of signum, which is real and odd function. Plus or minus 1 amplitude means real number, odd. What is the spectrum nature, sir? Imaginary and odd. Imaginary and odd. Vice versa. Last condition, I have to give some example for you. Wait for a few minutes. Imaginary even becomes imaginary even. For that, I have to give an example. Everyone tell me, what is the Fourier transform of a continuous impulse del of t? If you take a continuous impulse del of t, what is the Fourier transform? Answer 1. From the definition, integral del of t e power minus j omega t dt. From the definition, it is integral del of t e power minus j omega t dt or not. Integral has impulse means sampling or shifting property. Sampling or shifting property. So impulse exists at origin. Answer becomes 1 or not. E power j0. E power. The spectrum of impulse is constant for all frequencies. The spectrum of impulse is constant for all. Spectrum of impulse is constant for all frequencies. Out of the available signals, impulse is the only signal which contains all frequencies equally. Out of the available signals, impulse is the only signal which contains all frequencies equally. You select any frequency, what is its magnitude, sir? 1. But if you observe here, we have drawn the spectrum in the first case. They are not equally distributed. It is looking like a Gaussian spectrum or not, magnitude spectrum roughly. Gaussian spectrum. Out of the available signals, impulse is the only signal which contains all frequencies equally. Any frequency, its magnitude is 1 only, which is similar to white light concept. White light also contains all frequencies equally or not. That is the reason communication, what is the word used? Power spectral density of white noise is constant. Power spectral density of white noise is constant. Respect to autocorrelation function is impulse. Mathematically, we are studying that as n0 by 2, n0 by 2, delta, like that or not, sir? Tell me. What is Laplace transform of impulse function? Think and answer me. What is the Laplace of impulse? That is also 1. Laplace of impulse is 1. Very good. What is jet transform of impulse? That is also 1. Any transform of impulse is 1 only. Any transform of impulse is 1. Impulse in time domain is constant in frequency. Impulse in time domain is constant in frequency domain. Please answer me this example. Omega square plus 21 by omega square plus 9. That is a given spectrum. Find x of t. I have given spectrum. We want the signal. According to the formulas we studied till now, which denominator has the terms are omega square plus 9 style? According to the formulas we studied till now, which denominator has that quantity omega square plus 9? It is looking like two-sided exponential Fourier transform, not recollect. E power minus a mod t is 2a by a square plus omega square. E power minus a mod t is 2a by a square plus omega square. So denominator is looking like that way. 2a by a square plus. Enjoy. Find out what is x of t. Tell me the answer. Think. First of all, the given spectrum is proper. First of all, the given spectrum is proper. In partial fraction expansion, numerator power is, NR means numerator, sir. Numerator power is greater than denominator power is called as improper. If the powers are equal, then it is called as proper. If numerator power is less than denominator power, it is called as strictly proper. Numerator power greater than denominator is improper. If the powers are equal, proper. Numerator power less than denominator power is strictly. This is a proper function. Convert that to strictly proper. Omega square, numerator, denominator. Perform normal division to convert that to strictly proper form. So omega square plus 9, what you will get first? So that can be written as what, sir? 1 plus 12 by omega square plus 9. So the second term must be adjusted like which style? See the cursor. Second term must be adjusted like 2a by a square plus. So 1 plus omega square plus 3 square, numerator 2a, numerator 2a. So extra 2 is there because it is 12 multiplier. Now you write inverse Fourier. Now you write inverse Fourier, sir. Constant in frequency domain means impulse in time domain or not. Above only it is visible. When you take 1 in frequency domain, time domain, impulse. What is 2a by a square plus omega square? Answer, sir. 2a by a square plus omega square is e power minus a mod t. E power minus a mod t. By looking at the denominator only, you should get the thought it is linked to which standard formula. That idea you will get. That idea you will get only if you are thorough with standard formula. But you should recognize that omega square plus a square corresponds to which function, sir? Two-sided exponential. Convert the proper function to strictly proper by division. After that, you know the enjoyment. Constant in frequency becomes impulse. 2a by a square plus omega square means e power minus a mod t. Good. Most of you have answered. Good. So I am giving the next example for you. What is the inverse Fourier transform? This expression. 1 by 2 minus omega square plus 3j omega. Think and answer. What is the inverse Fourier transform of that expression? 1 by 2 minus omega square plus 3j omega. Come on, friends. Partial fraction only do build up. Karo. Hint for you, minus omega square can be adjusted as j omega whole square or not? J omega whole square expansion is what? Minus. Now you will know the roots in the denominator. It is looking like 1 by x square plus 3x plus 2. 1 by x square plus 3x plus. Now denominator can be written as j omega plus 1 into j omega plus 2. Denominator can be written as 1 by j omega plus 1 into j omega plus. Do partial fraction. 1 by a plus j omega is linked to our first formula or not? Take partial fraction expansion. For getting this residue, close the term with your hand. J omega place minus 1 means 1. For getting this residue, close the term. J omega place minus 2 means minus 1. J omega place minus 2 in the other expression. Everyone recollect? 1 by a plus j omega is our first relation. 1 by a plus j omega, sir. So what is the inverse for a? E power minus t ut minus e power minus 2t. Nothing is there, bacha. Writing this minus omega square as j omega whole square means you got the answer. Writing minus omega square as j omega whole square, sir. Good. Good. Most of you answered. Next standard signal which we are discussing is rectangular pulse. A rect t by t or A times pi of t by t. We followed two symbols for rectangle in the introduction. One symbol rectangle, rect t by t. Pi symbol also we used, sir. Rect t by t or A times pi of. It is a finite length signal which covers from minus t by 2 to plus t by 2. It is a finite length signal which covers from minus t by 2 to t by 2. Theoretically, to say rectangle in time corresponds to sap function or sinc function in frequency domain. Rectangular pulse in time domain corresponds to sap function or sinc function in frequency. So when you go by definition, sir, what are the integration limits to be varied now? Minus t by 2 to plus t by 2 signal amplitude A e power minus j omega t dt. Minus t by 2 plus t by 2 signal amplitude A e power minus. Further enjoyment what? E power minus j omega t divided by minus j omega over the limits. Over the limits minus t by 2 to. See here everyone, no tension. After substitution of the limits, a by j omega e power j omega t by 2 minus e power minus j omega t by 2. Just to substitute the limits, sir. Just substitute the. What is the extra adjustment we need to write this as sign term? What adjustment is needed? If you have in the denominator e power j theta minus e power minus j theta by 2j. E power j theta minus e power minus j theta by 2j means sign term or not? So further the answer is 2a by omega sine of omega t by 2. Our journey will go with this function. Listen carefully. Entire Fourier transform, 80% of my discussion is on this function. Listen very carefully. 2a by omega sine omega t by 2. Till here. 2a by omega sine omega t by 2. But This answer can be adjusted in two forms. One is called as a SAF function, which is sin x by x. Sin over its argument. SAF function expansion is sin function over its argument. In shortcut, SAF function. It can be also adjusted as sinc function or sinc pulse. Sinc x is denoted as sin pi x by pi x. Any fellow is denoting sinc x as sin x by x means it is wrong. Sinc function should always contain pi symbol, sir. Don't forget that. Sinc function should always contain pi symbol in the answer. Okay? How you can express sinc pulse as SAF functions are? SA of pi x. SA of pi x. Correct or not? So sin x by x form is called as SAF function. So sinc x is treated as what? Sin pi x by, in the place of x, if I substitute pi x, it becomes SAF function. So we have chance of adjusting our previous slide answer in two forms. One is SAF function, the other one sinc. What is SAF function form? Sin x by x. What is sin x by x requirement here? Everyone see here? X term is omega t by 2. If I have that in the denominator, if I have that term in the denominator, I can write or not. So 2a sin omega t by 2 divided by omega t by 2. What we adjusted? T by 2 multiplier we adjusted or not? So what is the new answer? AT SA omega t by 2. AT SA, or if you want to write in sinc form, AT sinc omega t by 2 pi. That is not a big deal. See, we said sinc x is SA of pi x. Assume pi x equals to lambda pi. That is what denominator, omega t by 2 pi. Omega t by. Okay. So rectangular pulse in time domain corresponds to which functions are? SAF function or sinc function. First I substituted in the definition, we got this expression. First I substituted in the definition, we got this expression. This answer can be written in two styles. One is SAF function or, what is SAF function definition? Sin x by x. Sinc function definition is what? Sin pi x by pi x. Sin pi x by, that way conversion we have done. So rectangular pulse in the time domain corresponds to SAF function or sinc function in frequency domain. Rectangular pulse in time domain corresponds to SAF function or sinc function in frequency domain. Good. Some of you are moving with me. What adjustment I asked? That also you have typed. Good, good. Be attentive in the class. Body present, mind absent means it is useless. Okay. Screen is on signals. Mind is going somewhere. So rectangle in time corresponds to SAF function or sinc function in frequency domain. So now we have to visualize this shape, sir. How we are going to get the SAF function shape? Roughly, first I am sketching. Sin x is a oscillating signal like this. Sin x is a what is the shape of 1 by x? As x increases, 1 by x decreases. As x increases, 1 by x decreases. Okay. Once you multiply these two, it is going to appear like this. Roughly, it's not exact curve. maintaining maximum amplitude at origin. Because limit extends to 0, sin x by x is what? Limit extends to 0, sin x by x is 1. Maintaining maximum amplitude at origin. For certain values of x, the result may be 0. For certain values of x, the result may be. This is sin x by x function. According to L'Hospital rule, indeterminate condition means L'Hospital limit extends to 0, sin x by x is 1 or not. Maintaining maximum amplitude at, for certain values of x, the result becomes 0. For certain values of, so roughly that is a graph. That is a graph of SAP function. But in the answer we discussed, before converting the to SAP function or sinc function, what is the answer we got before converting the to SAP function or sinc function? This is the answer or not, sir? See here, everyone see the cursor. Sin x equals to 0 means what is the general solution you can take? If you want to make sin x solution, plus or minus n pi, sin x equals to 0, indirectly for all integer multiples of 2 pi by t, the spectrum becomes 0 or not? 2n pi by t means for all integer multiples of 2 pi by t, the spectrum becomes. If I substitute omega place 2 pi by t, what is the answer? Sin pi by something, gone. If I substitute omega place 4 pi by t, sin 2 pi by something, gone. It means in our case, in this particular example case, the spectrum becomes 0 for all integer multiples of 2 pi by. Everyone see the graph carefully. Everyone see the graph carefully. Roughly the spectrum is going to appear like this. For all integer multiples of 2 pi by t, our spectrum becomes 0. For all integer multiples of 2 pi by t, the spectrum becomes 0. Maintaining maximum amplitude at origin. Maintaining maximum amplitude at. So this is Fourier transform of which function, sir? This is Fourier transform of which function? A symmetrical rectangle or not? Symmetrical. In our case, sin x equals to 0 means omega t by 2 equals to plus or minus n pi is the general solution. It means omega becomes plus or minus 2n pi by t. See the cursor, everyone. If I substitute omega place 2 pi by t quantity, sin pi by something, gone. If I substitute omega place 4 pi by t, sir, sin 2 pi by something, gone. For all integer multiples of 2 pi by t, the spectrum becomes 0. Maintaining maximum amplitude at origin. Maintaining maximum amplitude at origin. For GATE examiner, the favorite question is on this signal only. For GATE examiner. SAP function in shortcut SA of x means SAP. Instead of saying sin over its argument, tomorrow morning will come. Shortcut SAP. SAP function. For all integer multiples of 2 pi by t, the spectrum becomes 0. Everyone see the graph and tell me one point. This signal is real and even. Spectrum is also real and even. Just now we prepared a table. Where? Yes. This signal is real and even. The respective spectrum is also real and even. Satisfied or not? Signal real and even. Spectrum is real and even. Listen the points which I am explaining carefully. Listen the points. What is the area under the rectangle? What is the area under the rectangle, sir? AT. Area under the signal means where you are checking spectrum. Area under time domain function. Area under the signal means where we are checking spectrum at origin. What is the answer? AT means our condition is obeyed. Area under the signal means take spectrum at origin. Area under rectangle is AT. We got AT or not? Come on. Good. What is the bandwidth of the spectrum? What is the bandwidth of the spectrum? Ideal bandwidth is infinity. Ideal bandwidth is infinity. Spectrum is going up to infinite range, but its maximum energy is concentrated within the main lobe width. Some of the energy is wasted due to side lobes. Some of the energy is wasted due to practical bandwidth is 2 pi by t. Practical bandwidth is 2 pi by. Ideally, it is infinity, sir. Spectrum is going up to infinite range, but its maximum energy is concentrated in the main lobe. Practical bandwidth is 2 pi by. Some of the energy is wasted due to side lobes. Some of the energy is wasted due to side lobe. Certain times we are including the negative frequency also into consideration. Then it is called as spectral width. Then it is called as spectral width. What we learned in Fourier series, what is the significance of including negative frequency? Why we are including negative frequency in the spectrum, sir? To reproduce our real component as it is. Why negative frequency is included in the spectrum means to reproduce our real component as it is or not. So then in that case, it is called as spectral width. Bandwidth word is strictly valid for a positive range of frequencies only. Bandwidth word is valid strictly for positive range of frequencies only. Okay. We are including negative frequency only to recover back our original signal as it is. What is null to null or zero crossing bandwidth for the same spectrum, sir? What is null to null or zero crossing bandwidth for the same spectrum? Null means in the spectrum where the first zero crossing exists. At 2 pi by t, see the cursor, first zero crossing, immediate zero crossing, 4 pi by t. I used a bandwidth means positive range. What is this gap? First zero crossing 2 pi by t, next zero crossing. What is that gap, sir? 2 pi by. Bandwidth definition is not unique. Don't have that wrong thought, sir. Simply highest minus lowest frequency component. Bandwidth definition depends on the context. Absolute bandwidth, 3 dB bandwidth, RMS bandwidth, essential bandwidth, FCC bandwidth in communication. So under Parsel's theorem, by taking different signals, I will explain all the definitions. There are 6 different forms of bandwidth. Don't have a wrong thought. Bandwidth means simply highest minus lowest frequency component. That is a wrong thought. That is a wrong thought. Okay, don't have that wrong thought. It depends on the context. This is what in electromagnetics dipole, half power beamwidth, bandwidth first null. There we are learning half power beamwidth, bandwidth first null. In radar, to track the position of the target, we are transmitting streams of ones and zeros which are treated as rectangular pulses, where their spectrums must be observed. Maximum energy must be concentrated in the main lobe. Otherwise, they will enter into enemy zone. Some mishap may happen. Okay. Anyway, under correlation, I will give one practical example for you. That is not our emotion now. Checking the definition of bandwidth. Okay. Can a signal be time limited and band limited simultaneously? Can a signal be time limited and band limited simultaneously? It means, is it possible for us to take finite length in time as well as finite length in frequency? No chance. They can be infinite length in both domains, which are our starting examples. Just say decaying exponentially is infinite length, spectrum is also infinite length. But they cannot be finite length in both domains. They cannot be finite length in. So a signal A signal cannot be time limited and band limited simultaneously. A signal cannot be time limited and band limited simultaneously. That is what indirectly narrow band in one domain becomes wide band in the other domain. Narrow band in one domain becomes wide band in the other domain. A signal cannot be time limited and band limited simultaneously. You cannot have finite length in both domains. You cannot have finite length in both domains, sir. As we are going to use this formula multiple times, how to remember that relation easily? Let me explain. Whenever you take A rect T by T, what is the answer, sir? AT SA omega T by 2. That is the answer or not? A rect T by T means AT SA omega T by 2. Listen here. How to remember that in easy manner? How to remember that in easy manner? If you take a symmetrical rectangle from minus T by 2 to plus T by 2 with amplitude A, the fixed Fourier transform answer is what, sir? AT SA omega T by 2. AT SA omega. Everyone tell me what is the meaning of area under the rectangle or not? AT means area or not, sir? SA of omega, because we have to write in frequency domain SA of omega. What does that internal T by 2 represents? Internal T by 2 multiplier is the positive width of the rectangle or not? Without by hearting the formula, whenever you take symmetrical rectangle, first take area. AT means area under this rectangle or not? SA of omega, internal T by 2 multiplier is what? Positive width of the rectangle. Everyone say with me. Area. Area means AT. SA of omega, internal T by 2 multiplier is what? The positive width of the rectangle. Positive width of the rectangle. So, on your own, tell me this answer. Everyone. Suppose I have taken a symmetrical rectangle from minus 5 to 5 with amplitude 4. How I can write the answer directly? If I have taken a symmetrical rectangle from minus 5 to 5 with amplitude 4, first area term, what is area, sir? Area how much? 40 SA of omega into, what is the positive width of the rectangle? Come on, what is the positive width of the rectangle? 5 or not? 40 SA of 5 omega. 40 SA of 5 omega. T by 2 corresponds to positive width or not? Otherwise, what overaction you have to do? A value 4, T by 2 value 5. After that substitution, time waste for you. Simply area, 40 number here is area. Area under the rectangle, SA of omega into internal T by 2 stands for what here? The positive width of the rectangle or not? Positive width of the rectangle. First you habituate theoretically rectangle in time corresponds to which function in frequency? SAF function or sinc function? Rectangle in time corresponds to SAF function or sinc function in frequency domain. You want mathematical explanation? Are bacha, a rectangle, this rectangle is covered for what length? Just T units, but its spectrum is going up to infinite range. That is what this statement. A signal cannot be time limited and band limited simultaneously. The rectangle is just having length of T units or finite length, but spectrum is going up to infinite range. Don't forget this logic. Don't apply this logic emotionally for this rectangle also, only for symmetrical rectangle. Suppose you want See the cursor, sir. Suppose you want Fourier transform of this rectangle. What you have to do? First you take its symmetrical form, then you apply. First you take its symmetrical form from minus to 2, later on some property like shifting. Okay. I have mentioned with you symmetrical rectangle. For symmetrical rectangle, blindly apply this logic. AT tag is area, SA of omega into T by 2 is positive width. In this example, we solved what is area 40. SA of omega into positive width is how much? In time domain, positive width is 5 units or not? Very good. Rectangle in time corresponds to SAP function or sinc function in frequency domain. Rectangle in time corresponds to SAP function or sinc function in frequency domain. One very simple question I will give, answer me. Very simple model. Study this question and get the answer. Find the Fourier transform of the signal shown in figure. Good, good. Most of you answered the previous question. Very good. Very good. Find the Fourier transform of the signal shown in figure. The question asked is what? After finding the spectrum, we want the value at f equals to 1. F value 1 means what is equivalent omega number? 2 pi. F value 1 means omega is 2. First thought you require here is because it is finite length of constant amplitude, 100% it is rectangular pulse only. Because it is having constant amplitude with a finite length, 100% it is rectangular pulse or not, sir? Think of. It can be written as sum of two rectangles. It can be written as sum of two rectangles. See what are they? The given graph can be written as sum of two rectangles. One rectangle from -1 to 1, another rectangle from -2 to 2. One rectangle from -1 to 1, another rectangle from -2 to 2. Unsymmetrical, I will discuss the example. Don't get emotion. Sharma ji, wait karo. I will give explanation for that. Now onwards, so many times I will solve rectangular pulse. Don't take tension. Take one rectangle from -1 to 1. Take one rectangle from -1 to 1 with amplitude 1. Another rectangle from -2 to 2. Another rectangle from -2 to 2 with amplitude 1. Addition of these two signals is our y of t signal or not. Response, sir. When we add these two, 100% it is original graph. Come on, brother. You should respond. 100% it is original graph or not? Tell me, what is the Fourier transform of these two signals directly with our logic? Upper rectangle area, how much? 2 SA of omega into positive width is how much? Positive width 1 or not? Come on. Area 2, sir. First AT means area. SA of omega into positive width. Lower one, area 4. SA of omega into 2. Positive width is 2. Sum of these two is y of omega. Sum of these two is y of omega. What is expansion of SAP function? Recollect. S of x is what? Sin x by x. SA of x is sin x by, so 2 SA of omega can be written as what? 2 sin omega by omega. 4 SA of 2 omega can be written as what, sir? 4 sin 2 omega by, we want the answer at 2 pi, where the spectrum is expected at f equals to 1 means omega 2 pi. Sin 2 pi 0, sin 4 pi also 0, answer is 0. After finding out the spectrum, get the value at f equals to 1. Answer is 0. Correct or not? But by seeing this question, what is the first thought you need? Finite length of constant amplitude means it is related in terms of which function? Rectangle. That is the first thought you need. Finite length of constant amplitude means it is related in terms of rectangular function or not? Tell me. Good. Most of you have answered. Very good. If I ask in the same question, what is y of f at f equals to 2.5? What is the result? Same problem. If I ask y of f at f equals to 2.5, what is the result, sir? Huh? Then also what is the answer? 0 only. Because f value 2.5 means what is omega number? 5 pi, 2 pi f. F value 2.5 means omega 5 pi or not? Same enjoyment. Sin 5 pi 0, here sin 10 pi 0 or not? Sin 5 pi, sin. The given shape can be written as sum of two rectangular pulses. Sum of two rectangular pulses. Okay. Think and answer me this question. Another funny question. The magnitude spectrum of a function in figure A and another function y of t in figure B are given. Both are having phase angle 0. How to write yt in terms of x of t is the question. How to express y of t in terms of x of t? When you look at the two triangles given there, spectrums are. When you look at the two triangular spectrums given there, y of omega is neatly looking like compressed form of x omega or not. Y of omega spectrum is looking like compressed form of x omega or not. Of course, some amplitude scaling is there. Compression in frequency means what will happen in time domain. Compression in frequency means what will happen in time domain, sir? Expansion. Compression in frequency is expansion in time. Expansion means scaling factor less than 1 or greater than 1. Expansion means scaling factor less than 1 or greater than 1. Less than 1. So choice is between which options, sir? A and D. Choice is between A and indirectly we are applying time scaling property of Fourier transform. X of alpha t spectrum is 1 by mod alpha x of omega by alpha. It is very easy to remember. Time domain multiplied by alpha means frequency domain divided by alpha amplitude scaled. Funny thing is, this year ISRO paper, this is asked theoretically. Time scaling property of Fourier transform tells us if you want to scale the signal by alpha, not only frequency is scaled, it is amplitude scaled or not. Not only frequency is scaled, it is amplitude scaled by how much factor? 1 by You have decided y omega is compression of x omega, compression in frequency is expansion in time. Choice is between A and D. Options A and D. Choose the correct one, sir. Very funny question. Choose the correct one. Choice is between A and D. Compression in frequency domain means expansion in time domain. You can say y of omega is compression of x of omega. Y of omega is compression of x of. I can write y of omega as 3 into x of 2 omega. Amplitude scaling is there, sir. Here 1, here 3. Here 1 only there. Here 3. 3 into x of 2 omega. X of 2 omega means minus 50 to 50 range or not. Right side, we require this as our property style. X of 2 omega we require as our property style. 1 by mod alpha x of. Do the required adjustment. 2 omega can be written as omega by 1 by 2 internally. 2 omega can be written as omega by. Even 1 by mod alpha is also needed, which is not there. 1 by mod alpha is also required. It means what I adjusted externally, 1 by 2 I have adjusted. 1 by mod alpha x of omega by alpha, sir. X of 2 omega term, how I adjusted? Like x of omega by alpha. Still we want which tag? 1 by mod alpha means 1 by 1 by 2. Means 1 by 2 externally adjusted. This quantity is looking like property or not? So what is the inverse Fourier? Y of t equals to 3 by 2 x of t by 2. Alpha number 1 by 2 according to property notation. Alpha number 1 by 2 according to property. 3 by 2 x of t by 2. 3 by 2 x of t by 2. Good. After saying choice is between A and D, emotionally some fellows have taken A option. Vision 2021 becomes Fusion 2022. Be careful. We have to make that amplitude scaling adjustments carefully. Carefully we have to do that. Y omega is compression of x omega with amplitude scaling. 1 and 3 are given. That is the reason 3 into x of 2 omega. But what is scaling property style, sir? 1 by mod alpha x of omega by alpha. So internally what I have done, x of omega by 1 by 2. We need what tag? 1 by mod alpha is also needed, which is not there. So 1 by 2 adjustment done. This is x of alpha t. This quantity is x of alpha t. Okay. Please answer me this model. X of t is given as rect 2t. We want Fourier transform of x of 3t convolved x of t by 3. A signal x of t is given as rect 2t. Our style is a rect t by t. Our style is a rect t by t, sir. So we want Fourier transform of x of 3t convolved x of t by 3. Application of two properties, time scaling and convolution. Time scaling and convolution. Enjoy. Our style is A rect T by T form. Our style is A rect T by T. Come on. Have a thought. Rect 2T can be adjusted as what? In our style, if you want, rect of T by 1 by 2. Rect of T by, it means I can take the reference rectangle in symmetrical form where? If I write rect T by 1 by 2, I can take the reference rectangle, where is that? Minus 1 by 4 to 1 by 4. Minus 1 by 4 to, everyone tell me directly what is the Fourier transform? T by 1 by 2 width is half means minus 1 by 4 to 1 by 4 or not? So directly what is the Fourier transform? Area half SA of omega into positive width. Positive width how much? 1 by 4 or not? This is x of omega. I adjusted rect 2T as what? A rect T by T form. A rect T by T. So now it is neatly looking like symmetrical rectangle. Symmetrical rectangle, what is the direct way of taking the answer, sir? For symmetrical rectangle, this type. Rest of the story is application of the properties. What is the Fourier transform of x of alpha t from the previous slide? X of alpha t means 1 by mod alpha x of. So x of 3t means 1 by 3 x of omega by 3. Convolution becomes multiplication. Here 1 by 3 x of omega by. So 3 1 by 3 cancellation. X of omega by 3 into x of 3 omega. Just substitute the answer. Just substitute the. Here alpha 3, here alpha 1 by 3 according to property notation. Alpha 3 alpha. We already know x omega, substitute there, sir. We already know x omega. Good. Time reversal property and time scaling property we discussed it till now. Time reversal property, time scaling. Just to make a review, the formulas which we studied till now, I am writing this side. Just to make a review, sir, for it, till now. Decaying exponential transform pair with what? 1 by a plus j omega. Increasing exponential transform pair with what? 1 by a minus. Impulse uses constant. Two-sided exponential e power minus a mod t. 2a by a square plus omega square. Signum Fourier transform. 2 by rectangle Fourier transform. A rect t by t. What is the spectrum? AT SA omega t by 2. Just I am reviewing what we learned. What we learned in 1 hour till now is these relations. Last 1.5 hour explanation went on. these formulas. Of course, by using properties only, hello, I am audible now, friends. I am audible or not? Okay, thank you. Power is playing today. I don't know what is happening. Even we have backup, certain times it will happen. Sorry. So till now, in our discussion, these are the standard relations we studied, sir. What are they? Decaying exponential transform pair with 1 by a plus j omega. Increasing is 1 by a minus j omega. Impulse gives us constant. Rectangle in time is, come on, SAF function or sinc function in frequency domain. Correct or not? Rectangle in time corresponds to SAF function or sinc function in frequency. Next observation which we are making is called as duality or similarity property. Next observation which we are making is called as duality or similarity property. If xt transform pair with x omega, then capital X of t transform pair with 2 pi into small x of minus omega. 2 pi into small x of. What is the meaning of duality is in network theory, how we are learning duality generally in network subject. Voltage source becomes current source. resistance becomes conductance. Like that, what are the two domains now we have, sir? What are the two domains now we have? Time and frequency. See the cursor? You can convert the frequency domain expression to time domain by replacing omega as t, time to frequency by replacing t as minus omega. T as minus. How we got this? Let me explain with a simple explanation. What is the inverse Fourier definition we know, sir? Xt in terms of x omega, what we know? 1 over 2 pi integral x of omega e power j omega t d omega. That is inverse Fourier definition. That is inverse. If you replace t as minus t here, if you replace t as minus t here, what will happen? I am taking 2 pi also left side. 2 pi into small x of minus t integral minus infinity to infinity x omega exponential becomes negative. T place minus t. Directly t place. Next time interchange t and omega. Wherever t is there, write omega. Wherever omega is there, write t. What for you are doing this? Then only you will get the property. So 2 pi into small x of minus omega equals to integral minus infinity to infinity capital X of t. Exponential, both replacements are done, sir. D omega becomes dt. Whatever this last expression we got now, it is looking like forward transform definition of xt e power minus j omega t dt. So by definition, these two form transform pair. Capital X of t transform pair with 2 pi into small x of minus omega. By definition, they form transform pair. Actually, one application of duality is generally, for easy understanding, when we go to a photo studio, from the negative we are in a position to generate photograph or not. Photograph, by giving photograph also you can create the negative. Negative to photograph, photograph to negative. That is what, to understanding purpose, spectrum to time domain means omega replaced as t. Time domain to frequency domain means t is replaced as minus omega, which is based on inverse Fourier definition. The proof is based on inverse Fourier definition. Omega replaced as t, t replaced as minus omega. Omega replaced as t, t replaced as minus omega. Here you are modifying the spectrum to time domain. That is the reason spectrum expression no change, sir. That spectrum domain to time domain means omega plus t. So capital X remains same. Time domain signal becomes spectrum now. So t place minus omega. T place minus omega. So everyone tell me how to apply duality means. Every Fourier transform pair you can create the dual pair. For every standard Fourier transform pair you can create the dual pair. For that, what changes you have to make? Omega replaced as t, t replaced as minus omega. The stupid 2 pi tag, right side 2 pi tag is there not? Omega replaced as t, t replaced as minus omega. Based on the formulas we discussed till now, based on the standard formulas we discussed till now, I will give some example. Try to answer them on duality. Based on the standard formulas we studied till now, sir. I will give some standard examples for you. Be ready, everyone. Try to answer them. Suppose I have given 1 by 4 minus jt. What is the Fourier transform of 1 by 4 minus jt? We want Fourier transform of 1 by 4 minus jt. By looking at this expression, you should get the idea what is its original form. 1 by a minus jt. T place what we must have originally, sir. T place what we must have originally, omega. 1 by a minus jt stands for what? 1 by a minus j omega. Look after our previous slide. It is second formula or not? Look after our previous slide. E power at u minus t is 1 by a minus j omega or not? So think and answer me. Think and answer me that way. 1 by 4 minus jt means originally it corresponds to 1 by 4 minus j omega. Its original form. It is nothing but Fourier transform of which function, sir? E power at u of minus t. E power at u of applied duality. What we are doing in duality? Spectrum to time domain means omega place t, that is done. Listen. Don't paste it. Listen. Omega place t. This side 2 pi into small x of minus omega. So 2 pi into in the signal t place what we are substituting? In the signal t place what we are substituting? Minus. First this is given for us 1 by a minus jt. By looking at that we should get the idea what is its original spectrum form. 1 by a minus j omega. See the cursor. It is Fourier transform of growing exponential increasing. So omega replaced as t, t replaced as minus omega or not? T replaced as minus. Here small t place substitute minus omega. This is the answer. So when you are noting down this example, this is first available. From that we have written the spectrum. This is second available. From that we obtain the third, the time domain function, finally duality. Don't paste them in sequence. From here to we have gone here, from here to here, that way. From 1 by a minus jt we have taken spectrum, then time domain signal, finally duality. Finally duality. Okay. Good. Most of you answered very good. Those who have completed that, think about this one, sir. 2 by t square plus 1. Think and answer me. Those who have completed that. 2 by t square plus 1. Instead of t, originally it must contain what? Omega. Instead of t, originally it should contain omega. Think and answer me. Arey bacha, t place when you are substituting minus omega, how it becomes u minus omega? See here, the fellow who has asked me, wherever t is there, small xt is x of minus omega. So t place minus omega means 4 into minus omega. Here minus t is there, minus t means omega only. Dekho, t place minus omega. Think originally it is 2 by omega square plus 1 or not, sir? Instead of t, originally it is Fourier transform of which function? Two-sided e power minus mod t, a number 1, 2a by a square plus omega square. Now you apply duality. Now you apply omega replaced as t, t replaced as. But what is our property from previous slide? 2 pi into in the signal t place minus omega. 2 pi into in the signal t place. That is 2 pi e power minus mod omega. 2 pi e power minus. First, this is available. We have gone to this. From there, we obtained the time domain function. From that, the last point to duality. Don't paste the formulas in sequence. 1, 2, 3, 4 correct sequence I have written. What way the question is given? Don't paste the formulas, sir. Emotional fellows, be careful. Apply duality for signum function. Apply duality for signum function. What is signum formula? You already know. Signum spectrum is 2 by j omega r naught. Take this formula first. Signum Fourier transform is 2 by j omega. Apply duality property for that, sir. Apply duality for that. Signum Fourier transform is 2 by j omega. When we apply duality, omega place what we are substituting, sir? T. This side 2 pi into SGN of minus omega. Spectrum to time domain means spectrum expression to time domain omega place T. Time domain to frequency T place minus. Don't forget the stupid 2 pi. Problem gone. With scaling factors only, examiner will play with you. Omega replaced as T, T replaced as. As signum is odd function, this quantity is odd or not? As a signum is odd function, SGN of minus omega can be written as what, sir? Of course, cancellation of 2. Cancellation of. As signum is odd function, SGN of minus omega is what? Minus. Take pi on the left side. Take pi on the left side, cross multiply j. I am dragging pi on the left side, cross multiply j. 1 by pi t is having spectrum as minus j signum omega. 1 by pi t is having spectrum as minus j signum omega. 1 by pi t is having spectrum as minus j signum of omega. Everyone see here. 1 by pi t spectrum is minus j signum omega. See here, everyone. Signum amplitude is plus or minus 1, sir. Signum amplitude is plus or minus 1. Plus or minus 1 into minus j means plus or minus j. Tell me, due to plus or minus j, what is the phase angle contribution? Plus or minus 90 degrees. Plus or minus 90 degrees. This is called as Hilbert transformer. Hilbert transform is, it will provide additional phase angle of plus or minus 90 degrees. Whenever you take 1 by pi t as the system block, automatically what is the phase angle it is creating? Plus or minus 90 degrees. Signum amplitude plus or minus 1 into minus j means plus or minus j. See here, everyone. Signum amplitude plus or minus 1 into minus j means plus or minus j. Due to plus or minus j component, phase angle is 90 degrees. So whenever you want 90 degrees phase angle, what is the black box we are choosing? 1 by pi t. That is the purpose of defining signum Fourier transform by mathematical formula. From this mathematics, we are going to reality, how to generate 90 degrees phase shifter. From this mathematics, we are going to reality, how to generate 90 degrees phase shifter. Tell me, everyone, what is the Fourier transform of 1? I want Fourier transform of a constant. What is the Fourier transform of 1? For which signal we have defined Fourier transform as 1, sir? Respond, everyone. For which signal Fourier transform is 1? Del of t. Del of t Fourier transform is 1 or not? Del of t. As according to duality, spectrum to time domain means omega replaced as t. Here spectrum is independent of frequency, it is a constant number. Time domain also same, constant number. This side 2 pi into del of minus omega. 2 pi into del of, which is simply 2 pi del omega. 2 pi, what we studied in the beginning today. 2 pi del omega is equivalent to del F or not? 2 pi del omega is equivalent to del F. So impulse in time is giving constant in frequency. Impulse in time is constant in frequency. Opposite way, constant in time is impulse in frequency. Constant in time is impulse in frequency. Impulse in time domain is constant in frequency, first one. Second one, constant in time is impulse in frequency. What is the weight of the impulse, sir? 2 pi. So let us habituate theoretically. Impulse in one domain becomes constant in the other domain. Impulse in one domain becomes constant in the other domain. Impulse in one domain becomes constant in the other domain. To create 90 degrees phase angle, we need which black box? Black box response has 1 by pi t Hilbert transform that will create additional phase angle of 90 degrees. Everyone tell me how we express the signum in terms of step function, sir. What is signum in terms of step function? Signum is 2 into ut minus 1. One relation ut minus u minus t. Another relation 2 into ut minus 1. So what is u of t answer from this? 1 plus signum by 2. 1 plus. Now you will know what is the Fourier transform of ut. Step function Fourier transform, you can say, see our previous slide. 1 Fourier transform, how much? 2 pi del omega. See the previous slide, everyone. 1 Fourier transform, 2 pi del omega. Signum is 2 by. So for one answer is 2 pi del omega. Signum spectrum is 2 by 2. So what is the Fourier transform of unit step function, sir? 1 by j omega plus pi into del of step function is an energy signal or power signal. Constant amplitude or infinite time energy signal or power signals are power signal. So we have obtained its Fourier transform by mathematical approximation. Fourier transform power signals are obtained by mathematical approximation. Ut Laplace 1 by s, most of you know. Some emotional fellow have asked me, I want to use Laplace to Fourier. Pi del omega will not be there in Laplace. So you must be careful. Okay. Signum in terms of step function is 2 into ut minus 1. Ut is 1 plus signum by 2. 1 Fourier transform 2 pi del omega, sir, from our previous slide. 1 Fourier transform. Signum is 2 by j omega after simplification. Fourier transform of power signal we have defined as approximation to energy signal. Fourier transform of power signal we have defined as approximation to energy. U of t is a power signal. U of t is a power signal for which this is the spectrum 1 by j omega plus pi into del of omega. Laplace and Fourier, there is a slight difference. Don't get tension. The difference I will discuss. Because still we are in which domain? Fourier transform. Laplace transform will give neat explanation for you. Still some more examples are there to discuss. Take one short break. Already because of power cut, so many breaks were happened, sir. I am really sorry for that. take one short break, 20 minutes break. I'll come back. Okay. Okay, hope everyone came back. We are discussing examples related to duality property. In duality, what we are doing is spectrum to time domain means omega replaced as t, time to frequency means t replaced as minus omega in the signal time domain expression with extra 2 pi multiplier. Now let us try one simple example. What is the inverse Fourier transform of u of omega? What is the inverse Fourier transform of u omega? Ut becomes u omega means application of which property, sir? Ut becomes u omega means application of which property? Duality. Make a try. Make a try and tell me. What is the inverse Fourier transform of u of omega? Already hint is available left side. Ut spectrum we know. Ut spectrum we know. It is expected for u omega. Think and answer me. When we apply duality here, what we have to do, sir? For this formula, when we apply duality, omega replaced as a t. Omega replaced as, so this side 2 pi into u of minus omega. That is what our property or not? T place minus omega, omega place t. Omega place t, t place minus. But we want for u omega means how to convert this negative frequency to positive frequency. See the cursor. How to convert negative to positive, sir? Extra applied time reversal property, TR, time reversal property also. What is time reversal is t place minus t, omega place minus omega. T place minus t, omega place. So 1 by j into minus t plus pi into del of minus t. T place minus t. Take 2 pi, tag on the left side. The extra 2 pi multiplier on the left side. Omega place minus omega. The question asked is find the inverse Fourier transform of u omega. Ut spectrum just now we derived 1 by j omega plus pi into del omega. For that I applied duality. If I apply duality, omega replaced as t, t replaced as minus omega, sir. But how to convert that negative frequency to positive? Again, you apply reversal for this existing expression. Again, apply reversal. So t place minus t, omega place minus omega. We got the required question answer. We got the required question. Similarly, rectangular signal Fourier transform, what we studied? Rectangular signal Fourier transform, what we studied? SAF function or sinc function. Rectangle Fourier transform we studied as SAF function or sinc function. Vice versa, opposite also true. Opposite also. Just recollect that standard formulas we have written. where I have written that standard formulas. See here. A rect T by T means AT SA omega T by 2. A rect T by T means AT SA omega. So rectangle in time corresponds to SAF function in frequency. Listen carefully, sir. If I take a rectangle from minus A to A with amplitude 1, sir, it means it is rect T by 2A. Rect T by A rect T by T. What is the spectrum we have to write directly? What is the spectrum we have to write, sir? Area 2A SA of omega into positive width. Area 2A SA of omega into positive width of the. If you apply duality here, what will happen? If you apply duality here, omega plus T, T plus minus omega. Omega plus T, T plus. So 2A SA of AT, 2A SA of AT, this side, 2 pi into rect of small t plus minus omega. 2A SA of AT, right side 2 pi into rect of minus omega by 2 to cancellation. What is the expansion of SA of XR? See the cursor. What is the expansion of SA of X here? Sin X by X. Sin X by, as a rectangle is even symmetric, rect minus omega is taken as rect omega. As rectangle is even symmetric, rect minus omega is taken as. Drag that pi in the denominator. Sin AT by pi t. I have taken pi on the left side in the denominator. What is the shape of rect omega by 2A, sir? What is the shape of rect omega by 2A? Minus A to A, it covers with amplitude of 1. I have taken pi already on the left side. I have taken pi already on the left side. We studied in Fourier series this rectangular spectrum as which filter? Ideal low pass filter or not? Everyone recollect. We studied this rectangular spectrum as ideal low pass filter. So what is the ideal low pass filter? Time domain form. SAF function or sinc function. Whenever this expression comes, I will say SAF function or sinc function. Nothing to take serious about it. The reason is, if I am substituting A plus pi or pi by 2, it can be converted to sinc form. Of course, it is already SAF function with some adjustment. If I substitute A plus pi, pi by 2, 3 pi like that, it can be converted to sinc pulse or not, sir? Of course, it is already SAF function A by pi SA of AT. So whenever this expression comes in our discussion, I will say that as SAF function or sinc function. Don't take serious about that. So theoretically, to say rectangle in one domain, what will happen in other domain? Theoretically, to say rectangle in one domain, what will happen in other domain? SAF function or sinc function. So ideal low pass filter time domain representation is what, sir? Whenever you take ideal low pass filter, what is the time domain representation? Sin AT by pi t. Ideal low pass filter in the time domain is represented as sin AT by pi t. See here, I have taken rectangle from minus A to A with amplitude 1. We know symmetrical rectangle means how to write the spectrums are area 2A, SA of omega into positive width A, positive width of the rectangle A. After that, I applied duality. Omega becomes T, T becomes minus omega, 2 to jump. SAF function expansion is sin X by X. Rectangle is even symmetric. Because it is even symmetric, rect minus omega becomes rect. Pi also I have taken left side. Rect omega by 2A graph is this. So under duality, we observe two applications. One is the concept of Hilbert transform. 1 by pi t will produce 90 degrees phase angle. 1 by pi t will produce 90 degrees phase angle. Another one, ideal low pass filter time domain form is what? Sin AT by pi t. Sin AT by, in this expression, if I substitute a place pi, it is converted to which function? Respond everyone. If I substitute a place pi, sin pi t by pi t is treated as which function, sir? Sinc t or not? Sin AT by pi t. What is the Fourier transform of sin sinc t? Sin AT by pi t? A rectangle that covers from minus pi to pi. A rectangle that covers from minus pi to see one point, everyone listen carefully. Area under sinc function we want integral sinc t dt. I want area under the signal. Area under the signal means where spectrum must be considered. See here everyone, where spectrum must be considered, sir? At origin. What is the amplitude? 1. I don't know how to solve this mathematically. Integral sin pi t by pi t, how to solve, I don't know. But what is signal's logic? Area under time domain function means take the spectrum at origin or not. Spectrum amplitude at origin is 1. This is a standard formula. Integral sinc t dt is 1. Integral sinc t dt is 1. Area under sinc pulse integral sinc t dt answer is 1. बहुत 2 पे रे बच्चा, कहाँ है 2 पे? यहाँ पे 2 पे कहाँ से आता? कैंसिल हो गया ना यहाँ इधर. पाई भी डिनोमिनेटर पे ले लिया है. sin AT by pi t है तो a स्पेक्ट्रम है. a प्लस पाई लगा दो. sin pi t by pi t बोले तो sinc t है. उसको इंटीग्रेट करना है तो स्पेक्ट्रम ऑरिजिन पे लेना है. ऑरिजिन पे कितना है? एम्पलीट्यूड 1. एरिया अंडर सिंक फंक्शन इज 1. कहां से आता 2 पे आपको? दिस इज एरिया अंडर द सिग्नल. वी लर्न yesterday area under the signal means spectrum at origin, not area under rectangle. Spectrum at origin. Spectrum at origin is 1. But in our examinations, that fellow will never give. In our examinations, that fellow will never give the styles are sin AT by pi t, don't expect. Wantedly, he may give the problem like this. SA of 3t by 4, sinc 2t by 3. It may be asked for what is the spectrum. Everyone recollect. Either it is given as sap function or sinc function in time domain. First it must be converted to which style? Sin AT by pi t, then only you can draw the spectrum. Anything is extra means that becomes amplitude of rectangle. In our conversion, anything is extra means it is amplitude of the rectangle. Make it right, sir. I have given sap function and sinc function. I want the spectrum. Both are rectangular spectrums only. They must be converted to which form? Sin AT by pi t. Sin AT by. Enjoy. Do the required adjustments. I'm giving few seconds time for you. Do the required adjustments and tell me correct answer. Either it is sap function or sinc function, it must be converted to sin AT by pi t form. Sin AT by pi t form. First one can be written as what, sir? Sin 3t by 4 by 3t by 4 sin x by x. But what we need according to formula, sin 80 by pi t is needed. Pi is not there. I am adjusting extra pi. Sin 80 by pi t form is needed. So what is extra here? What is extra here? Sin 80 by pi t form means 4 pi by 3 sin 3t by 4 by pi t. 3 by 4 becomes 4, 4 by 3, 4 pi by 3 sin 3t by 4 by pi t. Now it is looking like our previous slide relation or not? Sin 80 by pi t appearance is there. What is A number, sir? So it is a rectangle that covers from minus 3 by 4 to 3 by 4 with amplitude of 4 pi by 3. If you take one, gone. Do the required adjustment. It must be converted to which style? Sin 80 by pi t. Anything that is adjusted extra becomes amplitude of rectangle. Anything that is extra becomes amplitude of the rectangle. Good. Very good. What about the second one, sir? Sinc x expansion is what? Sin pi x by sinc x expansion means sin pi x by pi x or not? Sin pi x by, so it becomes, do the required adjustment. Again, we want which form? Sin 80 by pi t form. Sin 80 by pi t form. So now what is the Fourier transform answer? Spectrum. It is a rectangle that covers from minus 2 pi by 3 to 2 pi by 3 with how much amplitude? 3 by 2. In a hurry, you may miss that amplitude levels. Be careful. You must be careful. Either that fellow will use sap function or sinc function. It must be converted to which form first? Sin 80 by pi t. Sin 80 by pi t. Like that, for every transform, Fourier transform pair, we can create the dual pair by making which changes? Omega plus t, t plus minus omega, right side 2 pi multiplier. Right side 2 pi multiplier. See here, one fellow wants still the explanation of this one. First we applied duality. Maybe he came just now. Omega replaced as t. Small t replaced as minus omega, sir. 2 cancellation. Sap function expansion is what? Sin x by x. I have expanded it. Okay, rectangle is even symmetric, so rect omega by 2a. A cancellation. I dragged pi on the left side. What is the graph of rect omega by 2a? Graph of rect omega by 2a is minus a to a with amplitude 1 because I dragged pi already on the left side. Never forget, he may give any form in time domain, sap function or sinc function. We should convert to which style, sir? Sin 80 by pi t. Anything is extra means we have chosen that as amplitude of rectangular spectrum. Come on, friends. We have chosen that as amplitude of rectangular spectrum or not? Good. For every transform pair, you have chance of creating the dual pair. Omega becomes t, t becomes minus omega. Omega becomes t, t becomes minus omega. Okay. Let us discuss the next point. Time shifting of Fourier transform. If xt spectrum is x omega, what is the Fourier transform of x of t minus t naught? Everyone tell me how we studied this in Fourier series, time shifting, yesterday's class. E power minus jn omega naught t naught into cn. Recollect yesterday's class. E power minus jn omega naught t naught into cn. What is the difference in Fourier series and transform, sir? What is the difference? Their discrete frequency now becomes continuous frequency. E power minus j omega t naught into x of omega. E power minus j omega t naught into n omega naught replaced as omega. So to convert Fourier series properties to Fourier transform properties, what is the change? Their discrete frequency n omega naught now becomes what? Omega. Their discrete frequency n omega naught now becomes omega. Because of time shifting property, phase spectrum changes. In e power j theta, what is the additional phase angle that is introduced, sir? In e power j theta, what is the additional phase angle that is introduced? Minus omega t naught. Phase spectrum is a straight line passing through origin with negative slope. Phase spectrum is a straight line passing through origin with negative slope. Okay. Phase spectrum changes. Magnitude is same. Modulus of this is mod x omega only. So because of time shifting property, phase spectrum changes. Because of time shifting property, phase spectrum changes. Magnitude remains same. Magnitude remains same. Time reversal property also has changed phase spectrum. Time reversal property also has changed phase spectrum. What is the Fourier transform of this function? What is the known signal for us, sir? In that expression, what is the known signal for us? E power at u minus t is the known signal. E power at u of minus t is the known signal. I want Fourier transform of e power 4t u of minus t plus 3. Think and answer me. Think whether it is right shift or left shift. Have a thought. E power at u minus t is the known signal. E power at u of minus t is the known signal. Decide whether it is left shift or right shift. Listen. If xt is taken as e power at u of minus t, if xt is taken as e power at u of minus t, what is x of t minus t naught meaning? E power a into t minus t naught u of minus of t minus t naught. E power a into t minus t naught u of, in the exponential power, for the given example, that shift is not there, means what adjustment you need? T minus 3 plus 3 is needed. Shift is neatly visible. T minus 3. T minus 3 plus 3 is, now it is in the correct form. Right shift. E power at u minus t plus 3 is given. First I have taken minus sign common such that we want t minus 3 in the power. But you have only t minus 3 plus 3, small adjustment. Okay. Now you take Fourier transform for this signal. Now you take Fourier transform. Before using property, what is the extra multiplier for sir? 4 3s are 12. Before using the property, 4 3s are. So because of time shifting, e power minus j omega t naught. Because of time shifting, e power minus j omega times Fourier transform of original signal e power at u minus t. Standard spectrum is what? 1 by a minus j omega. Known signal e power at u minus t 1 by a minus. Most of the fellows will miss this multiplier. See the cursor. E power 12 they will miss. Be careful. Most of the fellows will miss that. If the signal is like e power at u minus t, what is the shifted form? In the exponential power also we want t minus t naught, which is not there. After taking minus common, t minus 3, shift is required as t minus 3. Adjust that. T minus 3 plus 3, 4 3s are 12. Take it separately. Because t naught is plus 3 units, time shifting means what is the extra multipliers are? E power minus j omega t naught times Fourier of original signal 1 by a minus j omega. 1 by a minus j omega. Okay. It is right shift, not left shift. Most of the fellows will miss this multiplier. Problem is gone. Be careful. Be careful, sir. In the exponential power also, we need the shift. Then only you can apply the property. In the exponential power also, which is not there in the given signal. Which is not there in the given signal. Yes, sir. I think you have completed this model. Let me give another question for you. What is the Fourier transform of sinc of 2t plus 5? What is the Fourier transform of sinc of 2t plus 5? Which is the known function for us? Sin 80 by pi t form means sinc 2t is the known signal. Sinc 2t is the known signal. How e power 12? One more time. Arey brother, shifted version is e power a into t minus t naught, u of minus of t minus t naught. This is also same way. What is extra? 4 into 3. That is extra or not? 4 into 3, that is extra amplitude scaling. Let me write that step also. This is e power 12 into e power 4 t minus 3 u of minus of t minus 3. I think now your emotion is good. Having shift of 3 units, e power 12 extra multiplier on. E power 12. Think about this question, sir. We want Fourier transform of sinc 2t plus 5. Come on. We want Fourier transform of sinc 2t plus 5. For that, what is the hint? Just now we discussed duality. Sin 80 by pi t is the hint. Sync 2t is assumed as reference signal. Sync 2t. Make a try. You should assume sync 2t as reference signal, sir. Sync 2t is reference. Sin 80 by pi t form. Sin 80 by pi t form. Come on. We can write this as sync of 2 into t plus 5 by 2. That is taken as x of t plus. Assume x of t as sync 2t. What is the known signal for us here? That I am assuming as xt. Sync 2t is the known signal. If I substitute t as t plus 5 by 2 here, we are recovering our given signal. Everyone see here, see the cursor. If you replace t as t plus 5 by 2, we are recovering our original signal or not, sir? Enjoy. What is the spectrum of sync 2t? Sin 2 pi t by 2 pi. So Fourier transform of this one is what, sir? Sin 80 by pi t means a rectangle that covers from minus 2 pi to 2 pi. A rectangle that covers from minus 2 pi to 2 pi with amplitude. Recollect everyone. Sin 80 by pi t form. Sin 80 by pi t form. A rectangle that covers from minus 2 pi to extra scaling 1 by 2 is amplitude scaling or not? According to our property notation, what is the T naught number now, sir? Minus 5 by 2. According to property notation, see previous slide only property available x of t minus t naught form. So what is t naught number? Minus. When you apply Fourier transform, y of omega equals to e power minus j omega t naught into x omega. T naught is minus pi by 2. E power minus j omega t naught into, what is the mathematical expression of this rectangle? 1 by 2 rect omega by 4 pi. 1 by 2 rect omega by 4 pi e power j 5 omega by 2. E power j 5 omega by, correct or not? Shift of minus 5 by 2. Shift of minus. Sync 2t, we got the spectrum amplitude of 1 by 2. Recollect everyone, sin 80 by pi t means rectangular spectrum under duality. Just now we discussed, sir. Sin 80 by pi t means rectangle minus 2 pi. Extra scaling factor is amplitude. Extra scaling factor is amplitude. Nothing is there. Check the shift properly, known signal properly. Sync 2t known signal. In our previous question, what is the known signal? E power at u minus t is the known signal. After that, checking shift. With the plus minus sign only, problem will go. You must be very careful. Plus minus sign, plus and minus sign only, problem will go, sir. Let me see now how many of you will give correct answer. Rect of t plus 5 by 4. I want Fourier transform. Rect of t plus 5 by 4. Rect of t plus 5 by 4. Known signal for us is rect T by 4. A rect T by T is standard form. A rect T by T, standard form, sir. Rect of T plus 5 by 4. How many units of shift you tell me? I want T naught number. X of T minus T naught is our notation. Tell me what is T naught number. Come on, friends. Rect T by 4 standard form. What is T naught number? Different answers you have given. Carry on. Think. Rect T by 4 is the known signal. T naught becomes minus 5. Z of T can be written as X of T plus 5, where X of T is rect T by 4. The known signal we are assuming as rect T by 4. Okay. If you substitute T as T plus 5, we are recovering our signal. If you substitute T as anyway, rect T by 4 means that rectangle covers from minus 2 to rect T by 4 means rectangle covers from minus 2 to. Everyone tell me what is the direct Fourier transform answer we should write, sir? Area for SA of omega into positive width. Symmetrical rectangle direct logic, area for SA of omega into positive width. T naught is minus 5. T minus T naught style. T naught is minus. So what is the Fourier transform answer? E power minus j omega T naught into x of omega. You know x omega, substitute there. Rect T by 4 is reference signal. If you take shift as minus 5 by 4, gone. A rect T by T standard form. Rect T by 4 is reference signal. Don't take T naught minus 5 by 4. If you assume T naught minus 5 by 4, this expression becomes T plus 5 by 16. You are changing the given expression. Don't do that. Rect T by 4 standard form, shift of minus 5, sir. Because if I replace here T as T plus 5, 100% our original signal only. 100% our X omega answer available. You substitute there. X omega answer available. A rect T by T form. So rect T by 4 separately I have taken. We obtained the spectrum with T naught minus 5 because of shifting e power minus j omega T naught times original spectrum. E power minus j omega T naught times original spectrum. Yes. Now you think. The Fourier transform of a triangular pulse f of t shown below. F of t is given, the respective spectrum is also given, sir. Using this signal as reference, find the Fourier transform of other two signals, F1t, F2t signal spectrum we want. Think and answer me. How to write F1t in terms of f of t, you should tell me. How to express F1t in terms of f of t with respect to the properties we studied till now, reversal, shifting or time scaling. Don't apply differentiation. And that too, rectangle means sinc or sap function. Directly we know. I am using properties. What are the known properties still now in the chapter? Time reversal, time scaling, time shifting. Tell me how to write f1t in terms of f of t. How to write f1t in terms of f of t? Think. Don't apply differentiation. I am asking with respect to the known properties. There is no need to apply differentiation also because we know rectangle means sap function. I am asking with respect to the known properties till now. In this chapter, what we learned till now? Linearity we learned, reversal we learned, scaling we learned till now. Of course, shifting. Shifting we started. What is the folded version of f of t? What is the folded version of f of t, sir? This blue signal, folded version of f of t. If I take f of t right shifted by 1 by 2 units, if I take f of t right shifted by 1 by 2 units, where it covers? Minus half to half. F of t right shifted by 1 unit. Similarly, this folded signal left shifted by 1 unit. Similarly, this folded signal left shifted by 1 unit. Sorry, left shifted by 1 by 2 unit. F of minus t left shifted by 1 by 2 unit means where that graph will cover minus half to half or not? Minus half to, come on, respond. What is sum of these two signals? If I add them, what you are going to get? Positive ramp added to negative ramp means constant number 1 unit. Add the amplitude, it becomes 1 or not? Positive ramp added to negative ramp means it becomes constant. Okay. How we got shift of 1 by 2 unit idea? Because a rectangle covers from minus half to half. Very good. So many of you have tried. As rectangle covers from minus half to half, we will get the thought that it must be right and left shifted by 1 by 2 units. Okay. So f1 of t equals to f of t minus 1 by 2 one term added to f of minus of t plus folded signal left shifted. This f of minus t left shifted by 1 by 2. Left shifted by anyway. T naught equals to plus half for the first time. In the second expression, it is minus half or not, sir? Because t minus t naught is our symbol. T minus. What is the Fourier transform for this expression? F1 of omega equals to e power minus j omega t naught into f omega plus e power minus j omega t naught into, instead of f of t, what is there, sir? Instead of f of t, f minus t means it becomes f minus omega. Two properties, shifting, reversal. F minus t means f minus. This is having positive shift t naught 1 by 2. This is having negative shift and reversal. After application of shifting, f minus t means f of minus omega. Now you think about how to write f2t in terms of f of t. Have a thought? How to express f2t in terms of f of t, sir? Come on. method. This is T naught. I think more pasting I have done. T naught. Think about how to express F2T in terms of F of T. Come on, sir. When you look at F of T, its length is 1, but F2T length 2 units means first we have to expand it. First we have to F of T length 1 unit, but F2T length. So if I take F of T by 2, it extends from minus 2 to 0, sir. If I take F of T by 2, it extends from minus 2 to. If this is right shifted by 2 units, we are getting F2T or not. Of course, change in amplitude. See the cursor. If F of T by 2 right shifted by 2 units, we are getting this answer. So, you can say F2 of T as 1.5 F of T minus 2 by 2. Scaled signal is shifted. F of T by 2 is the scaled signal that is shifted. I have written two expressions here. You tell me which is correct one. F of T by 2 is the signal that is right shifted by 2 units. First one correct or second one correct? Just a minute. Why this is always dancing? Just a minute. Yeah. Scaled signal is shifted, sir. Scaled signal is shifted. So tell me which is correct. First one or second one? Just recollect our introduction. F of alpha T is the scaled form. Shifted form means alpha into T minus T naught. Alpha into T minus. F of T by 2 means T minus 2 becomes common shift. Anyway, according to our property notation, alpha 1 by 2 shift of 2 units. According to our property notation, alpha 1 by 2 shift of. Apply the properties. 1.5 first scaling. F of T by 2 means 1 by mod alpha F of omega by alpha. 1 by mod alpha F of omega by alpha. Because of shifting, sir, e power minus j omega T naught. E power minus j omega. First you apply scaling 1 by mod alpha F of omega by alpha. Because of shifting e power minus j omega. Why extra 1.5? Original amplitude 1, but this F2T signal amplitude 1.5 or not, sir? Scaled signal shifted. Just recollect our introduction. F of alpha T is the scaled signal means what is the shifted form? Alpha into T minus T naught. Alpha is 1 by 2 number for us. Now, alpha into T minus. Scaled signal is shifted. F of alpha T shifted means alpha becomes common multiplier. Alpha becomes common multiplier. There are so many ways to answer this question, but With respect to the known properties, till now we have done that in this chapter. Okay, just ideas, different ways. Final spectrum answers must be same. You follow any method. Final answer of the signal spectrum must be same. Okay. Still, most of you have given wrong answer. Second one. Check your basics. F of alpha t shifted version means alpha into t minus naught. But here I have written t by 2 minus 2 gone. 2021 gone to 2022. Be careful. Be careful. Scaled signal shifted. First class only I discussed that point. What mistakes you will do definitely in signal subject. Be careful, sir. First one is correct, not second one. Good. Okay. The next property which we are discussing now is called as frequency shift. In communication, the habituated word is modulation. Frequency shift or modulation property. A signal x of t is having spectrum as x of omega means if you want to shift the spectrum by omega c, what will happen in time domain? Signal multiplied by complex sinusoid. Signal multiplied by complex sinusoid. Or xt e power j2 pi fct. Omega c expansion is what, sir? Omega c expansion is 2 pi becomes x of f minus fc. X of f minus. Why the word modulation? Without this property, there is no information transmission. Most of you are aware, modulation means conversion of low pass spectrum to band pass spectrum. Fundamental reason we require this property is we want to reduce the size of antenna. Our voice signal, if you want to directly transmit that, which has approximately 3 kHz bandwidth, 300 to 3400 Hz means 3 kHz bandwidth. What is the wavelength of the antenna? Velocity of light by frequency 3 into 10 power 8 by 3 into 10 cube. Just we want 100 kilometers antenna, which is impractical to design. From Hyderabad to half distance of Vijayawada, middle so much emotion will be there. For that reason, we are shifting this to a new band like megahertz. If you shift this to megahertz, there is a chance of reducing the length to 100 meters. We are retaining the same frequency at a different place. We are retaining the same frequency at a different place. How that is done? Observe here. Suppose we have taken a reference spectrum like this, sir. Suppose we have taken a reference spectrum like this. The bandwidth of the spectrum is 1 kilohertz. The bandwidth of the spectrum is 1 kilohertz. If you say x of f minus 1000, same triangle is retained at a different place. But what is the advantage you are getting, sir? 1000 kilohertz means 1 megahertz. By retaining the same information at a different place, what advantage you are getting? You can reduce the size of the antenna. When we tune to any radio station, the carrier frequency is megahertz. But a boy or girl are speaking, which is voice information. Even with negligible size of antenna, we are in a position to receive the signal. Correct or not? So the fundamental reason for selecting this property is what? To reduce the size of the antenna. See the cursor? Whenever the low pass signal xt is multiplied by a complex sinusoid, that will cause shift of the spectrum. Modulation means it will reduce interference, noise, so much buildup is there, sir. Fundamental reason for selecting this property is what? To reduce the size of antenna. To reduce the size of antenna. Okay. So a signal multiplied by complex sinusoid means we are using frequency shifting property. Signal multiplied by complex sinusoid. Listen everyone here. Suppose the question is find the Fourier transform of cos function. What is cos in terms of exponential? E power j omega naught t plus e power minus j omega naught t divided by 2. Expand cos theta. For the this property, I am adjusting one extra such that it is looking like our property symbol xt e power j omega. What is the Fourier transform of 1 already we know, sir? 2 pi del omega. One Fourier transform is known as 2 pi del omega or not? So based on frequency shifting property, signal multiplied by exponential means the spectrum shifted by how many units? 2 pi into del of omega minus. Next time, what is the shift value? 2 pi into del of omega plus omega naught whole divided by 2. So when you take cosine function in the time, what it has retained in the spectrum, sir? You have two spikes directly at plus or minus omega naught. Spikes means impulses. The weight of each impulse is pi or not? The weight of each impulse is cos omega expansion is e power j omega naught t plus e power minus j omega naught t by 2. For the application of modulation property, what I have done before exponential, I adjusted one, sir. xt e power j omega ct form. Spectrum shifted by plus or minus omega naught. Everyone tell me, cos is a real and even function or not? Cos is a real and even function or not? Come on, automatically what is the spectrum? Cos is real and even function means what is the nature of the spectrum, sir? Come on. Real and even. The spectrum is real and even or not? Cos function is real and even. Spectrum is real and 100% our theoretical statements will be obeyed. Any place you can cross check it. Any place. In a similar way, what is the change for sine term without solving? What is the Fourier transform of sine term? We can say pi by j del of omega minus omega naught minus del of omega plus. What is there, sir? Middle minus divided by 2j or not? Middle minus divided by. So pi by j del of omega minus omega naught minus del of omega plus omega naught. Sine is a odd function. Real and odd function means spectrum is imaginary and odd. Just listen. In a similar way, suppose I want what is the Fourier transform of a damped sinusoid, sir. If I want Fourier transform of this function, damped sinusoid, for the application of our property, it must appear like which style? xt e power j omega ct for the application of this property. So which is assumed as xt, sir? E power minus 3t ut is xt, right sign in terms of exponential. Blindly this property or not? Assume e power minus 3t ut as reference, right sign in terms of exponential. Not only that, suppose I want Fourier transform of a radio frequency pulse rect t by 6 into cos 40 pi t, that is called as RF pulse, radio frequency. Now signal you will assume as reference. Rect t by 6 is like xt, known signal rect t by 6. If you write cos in terms of exponential blindly, which property again? Frequency shifting. Don't solve the examples in hurry manner. Listen first. So when there is a need of applying frequency shifting property, whenever any signal is multiplied by complex sinusoid cos or sine function, take the other segment as reference and apply frequency shifting. Whenever any signal multiplied by complex sinusoid cos or sine function, it is indication of applying which property? Frequency shifting. Listen. In this case, rect t by 6 we are assuming as xt, sir. In this example, e power minus 3t ut is reference. In the problem we solve, what is reference? 1 is reference. So what is the point to be noted here? When there is a need of applying frequency shifting property, any signal multiplied by cos, sine or complex sinusoid e power j omega ct, it is not real. Complex sinusoid is indication of applying frequency shifting property. Any signal multiplied by cos term, sine term or complex sinusoid is indication of applying frequency shifting property or not? Just go through it. Go through the graph. Any signal xt multiplied by complex sinusoid or sine term or cos term, take the other signal as reference and blindly apply frequency shifting or not? Tell me. Just go through the property, everyone. Signal is real and even means what is the nature of the spectrum, sir? That is also real and even. Again, we cross-checked the known point only for us. Cross-checked the known point. Any signal multiplied by cos, sine or exponential. Exponential means complex sinusoid. It is not real exponential. Complex sinusoid. What is there, bacha? Magnitude of these impulses, but phase angle at omega naught minus 90 minus omega naught plus 90. Imaginary odd means definitely it will have phase spectrum extra. Magnitude of both impulses phi. Because of j component at plus omega naught minus 90 minus omega naught plus 90, like that. Now you try one very simple question I will give. Please answer me this very simple example. We want Fourier transform for sinc t into cos 10 pi t. See the right side thing. So just now what you have stated, sir. See the cursor. Any signal multiplied by cos, sine or complex sinusoid is indication of applying which property? Frequency shifting. Think and answer me. Sinc t is assumed to be reference signal or not? Write cos in terms of exponential term. Sinc t is taken as reference signal xt. Cos 10 pi t expand in terms of exponential, you can get the answer. Make a try. Assume sinc t as reference. Assume sinc t as reference. So it can be written as x of t multiplied by, what is cos expansion, sir? e power j 10 pi t plus e power minus j 10 pi t by 2. Everyone tell me what is Fourier transform of sinc t directly. Sinc t expansion is sin pi t by pi t. Sin pi t by. So it is a rectangle that covers for what range? Minus pi to pi. Minus pi to pi. Sin 80 by pi t means rectangle from minus pi to. From our previous slide, it is looking like xt e power j omega ct form or not, sir? First time what is omega c number? Plus 10 pi. Next time what is omega c number? Minus 10 pi. First time plus 10 pi, next time minus. So if I take Fourier transform here, y of omega equals to x of omega minus 10 pi plus x of omega plus 10 pi whole divided by 2 whole divided by 2. It means this rectangular spectrum right and left shifted by how many units, sir? 10 pi units. Rectangular spectrum right and left shifted by 10 pi units. Change in amplitude is 1 by 2. Change in amplitude is 1 by 2. Correct or not? Sinc t is the known signal, known function. We assumed that as reference. Sin pi t by pi t. We know this spectrum. So many problems. Today already it is 7th or 8th question on that function. So first time omega c plus 10 pi. Next time omega c minus 10 pi. This is right and left shifted by 10 pi units. Don't forget the scaling factor 1 by 2. Bacha, what is their ideal low pass filter converted to ideal band pass spectrum? Originally ideal low pass filter, now it becomes what, sir? Come on. Ideal low pass filter converted to ideal band pass filter. Good, good. X of t is the known signal sinc t for which this is a spectrum rectangle from minus pi to pi. Make right and left shift of 10 pi units. Amplitude scaling of 1 by 2. Amplitude scaling of 1 by 2. The same question, one small change I will make. In the same question, answer. One small change I will make. What is that is? What is the inverse Fourier transform of spectrum shown below? What is the inverse Fourier transform of this spectrum given? Its amplitude is everywhere 1 except in which range? 0 to 2 pi. Y of omega I have given, I want yt. One hint is its amplitude is everywhere 1 except in which range? 0 to 2 pi. I have given in frequency domain. Its amplitude is everywhere 1 except in which range, sir? 0 to 2 pi. So from 1 you have to subtract a rectangle from 0 to 2 pi range or not? That is a hint. From 1 you have to subtract a rectangle from 0 to 2 pi. Tell me, have a thought? Have a thought? From constant amplitude of 1, subtract it. This can be written as 1 from that subtracting 1 minus of this one. When you subtract from 1 this, we are retaining this graph or not, sir? Listen here. When we take rectangle from minus pi to pi, even in the previous slide also it is there. See our previous slide. When you take rectangle from minus pi to pi, what is the time domain function? Sinc function or not? Assume this is x omega. So the inverse Fourier becomes what? Sinc t. Sinc. So we can write that as y of omega equals to 1 minus of x of omega minus pi. Everyone see here, sir? This is 1. If I make right shift of pi units, we are retaining this rectangle or not? So what is the inverse Fourier? Y of t equals to constant in frequency means del t. According to frequency shifting property, x of omega minus omega c, now that omega c number pi or not. So it is xt e power j pi t. Del t minus sinc t e power j pi t. Del t minus sinc t e power j. Nothing is there. The simple thought you need is the spectrum amplitude is everywhere 1 except in which range? 0 to 2 pi range. So from a constant amplitude of 1, try to subtract this rectangle. Rectangle means immediately what is the thought you need? Here the width is 2 pi. If I take a symmetrical rectangle from minus pi to pi, we know it is sinc function. So this is right shifted by pi units. That is what I have taken here. Right shifted by over. We got the time domain function or not? Tell me. With the two simple questions on today's discussion, I will end the class. But you have to answer me, not simply directly ending. Two simple questions I will give. One question is, what is the inverse Fourier transform of x of 4 omega plus 3? I have given spectrum. I want in terms of xt. What is the answer, sir? What is the inverse Fourier transform of x of 4 omega plus 3? In terms of xt, you tell me the answer. And what is the Fourier transform of this term? Only application of properties I have given. Left side spectrum domain, right side time domain. Think and answer me. Very good. Last example, most of you have answered. Very good. What is the inverse Fourier transform of x of 4 omega plus 3? Come on, sir. It is indicating application of two properties. One is modulation. Omega becomes 4 omega is scaling. This can be written as 4 into omega plus 3 by 4. This can be written as omega 4 into omega plus 3 by 4. I will always follow first scaling then shifting logic. Anyway, omega c number is minus 3 by 4. First, let us decide about x of 4 omega term, sir. Separately, I am solving x of 4 omega. We want this like which style? 1 by mod alpha x of omega by alpha. 1 by mod alpha x of omega by. So for that we need an adjustment or not. 1 by mod alpha x of omega by alpha means we need adjustment. So 1 by 4 also extra needed. What is the inverse Fourier of this term, sir? 1 by 4 x of t by 4. Only for x4 omega I solved separately. 1 by 4 x of. Now you tell me what is the inverse Fourier we can write. Only for x of 4 omega what you have written? 1 by 4 x of e power j omega ct. E power j. This is the final answer. Whenever the problem contains scaling and shifting, I am applying first scaling then shifting x of 4 omega, but time scaling form we are expecting which style? Time scaling form we are expecting like which style, sir? Recollect. X of alpha t means we want 1 by mod alpha x of omega by alpha. That way you make the required adjustment. So 4 omega can be written as omega by 1 by mod alpha is also needed, which is not there. We got this. After getting x of 4 omega inverse, omega c number minus 3 by 4, signal multiplied by complex sinusoid. How many of you have done correctly without a single mistake? Left side expression. How many of you have done correctly, sir? Without single mistake. Okay. Let us see the right side thing. Right side thing, application of time scaling, time shifting, frequent shifting. Three properties. Time scaling, time shifting. I am writing this as z of t into e power minus j phi t. Isn't z of t into, it means z of t I am assuming as what, sir? X of 2t plus 3. I am assuming z of t as what? X of 2t plus 3. No. Most of you have given wrong answer in the beginning. Finally, some of you have said me. Me means you have done correctly or wrongly. Okay, no problem. Assume this as z of t. So this can be written as x of 2 into t plus 3 by 2. 2. 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 2 alpha is 2, T naught is minus 3 by 2. X of alpha T form alpha 2, sir. T minus T naught shifting form T naught is minus. What is Fourier transform answer I can write? 1 by 2 x of omega by 2. X of 2t means 1 by alpha x of omega by alpha. Because of shifting e power minus j omega t naught is minus 3 by 2. For x of 2t 1 by alpha x of omega by alpha. Because of shifting e power minus j omega, this is done. Of course, here it is neatly indicating only for this term frequency shifting property. Z of t e power j omega c t form. So y omega equals to z of omega minus omega c. What is that omega c numbers are property notation? It means z of omega plus in the known spectrum. Omega place what you are substituting? 1 by 2 x of omega plus 5 by 2 e power j omega plus 5 into 3 by time scaling is there, time shifting is there, finally frequent shifting. Separately for convenience, I assumed x of 2t plus 3 as z of t, which includes both scaling and shifting, sir. First x of 2t means what is the spectrum? 1 by alpha x of omega by, because of time shifting e power minus j omega t naught multiplier. Finally modulation, wherever omega is there, omega plus 5. How many of you have done correctly now? This last example. Oh, most of you have typed. Some of you have typed wrong answer also. Very good. Be careful with scaling shifting properties. You must be careful. Okay. Today ज़्यादा हो गया. Take rest. Thank you. Tomorrow we'll meet again. Those who have doubt, they can stay back. Okay. Thank you. Okay, let me start one by one.
Audible, sir?
Sir,
Hello.
tell me.
Sir, in this example, we need to adjust in numerator e raised to term also.
E power?
E raised to term, in e raised to term also, we need to adjust plus
This
5.
breaking here. Your voice is
This
breaking.
example.
Your voice is breaking.
Sir, in given example,
Right
we
side,
took e raised to j omega plus
C.
5.
Omega c is which number? This,
Sorry?
this e power j omega ct na. What is omega c number here? Minus 5.
Right.
Modulation. देख लो वहां पे क्या लिखा? इधर देखो.
I took
e power j omega ct बोले तो x of omega minus omega c है ना. Omega c इधर minus 5 है. Substitute करो.
Okay. I took only in x of omega plus 5. So that was
complete term.
e raised to term I didn't take.
Yes. Okay.
Okay. Sir, previous page, but I don't know the number exactly. Can you just go?
This one?
No, just go forward. I will stop you. I don't know the exact page.
Which point? Which point you tell me? I will show the slide.
That was sir question only. Wait a minute.
There are so many questions here.
No, that is right.
Tomorrow you can ask me. Tomorrow you ask.
Sir, that sample question, rectangle.
Rectangle SAP function. क्या है?
Rectangle of t plus 5 divided by 4. That was the question.
Oh, shifting property. Okay. Wait. क्या है? बोलो. Slide available.
So I didn't get this question, sir.
What is there? I asked what is the Fourier transform of recta t plus 5 by 4. Our standard rectangle form is recta t by t ना. इसीलिए recta t by 4 reference signal है. Shift तो left है -5. So directly if you replace t as t plus 5, we are recovering back our original expression. No problem. Simple shifting sufficient.
Sir, I got 4 sample of 4 omega e raised to 20 j omega. I don't know.
20 how you will get here? Shift you have taken probably wrongly. -5 by 4 shift if you take it is wrong. Shift is -5 only. Shift is -5 only.
Okay.
Cross check. Somewhere you have done mistake. Cross check.
Okay. Got it, sir. Got it. Thank you, sir.
Yes.
Hello, sir. Sir, I have two problems, sir. There is a statement given as for an LTI system, cos omega naught t can be treated as an eigen signal. Is it true or
It's not
false?
100% eigen because cos may become sin also, but they are treated as eigen function. No problem.
So,
I am going to discuss that point in Laplace for 1 hour. Only that cos and sin function examples.
they have given here answer as a into cos omega naught t passed through h of j omega equal to a into mod of h of j.
That's what cos. When you apply a pure sinusoid to an LTI system, it will introduce some magnitude and phase change.
Okay.
So 100% eigen functions are only exponential. Cos may become sin, sin may become cos when you pass through integrator. But what is eigen function concept? Input form, output form must be same. So based on that, 1 hour discussion will be there in Laplace. Wait.
Okay, sir. Here another problem. Let x of t be a periodic signal for Fourier series. Coefficients are Cn equal to 2 for n equal to 0 and Cn equal to j into 1 by 2
1 by 2 whole power modern. Na?
Yes,
Today
sir.
I discussed one table are real and odd becomes imaginary odd today.
Sir, I solved the Cn and I got 2 minus j4, sir. I couldn't able to.
N is already given. How will solve for Cn?
I expanded those all, sir.
Just wait. I will discuss that condition. Just wait. See, in Fourier series, x conjugate t complex signal means c minus n conjugate ma.
Yes,
how
sir.
we studied even conjugate time domain? How we studied even conjugate? You tell me. X of t must be equals to x star of minus t na.
Yes, sir.
So with respect to Fourier series, xt means cn. X conjugate of minus t means if I place minus t here it becomes, if cn equals to cn conjugate, that given signal satisfies even conjugate behavior. Similarly, what is odd conjugate behavior? Xt equals to minus x conjugate of xt. So with respect to Fourier series, if cn is minus cn conjugate, I think this will be obeyed. See there, cn equals
sir.
minus cn conjugate. So
They have given this explanation, sir. I didn't understand them.
Okay, sure though.
Okay, sir. Thank you, sir.
Yes. Yes, ma.
This last problem, sir, 1 minus x of omega minus pi. I didn't get it, sir.
Slide.
Last one.
This one. This one?
No, sir. After that.
Previous. What is there to get? I have given frequency domain spectrum. I want time domain function. This spectrum amplitude is everywhere except in which range? 0 to 2 pi. It means from 1 I have to subtract a rectangle or not?
Yes, sir.
We already know rectangle in frequency domain means sinc or sap function. Because its width is 2 pi, I assumed reference rectangle from minus pi to pi. This is Fourier transform of which function? Sinc function. Correct or not? If I make right shift of pi, I will get this. Because I assumed that as x omega, I have written x of omega minus pi. Take inverse Fourier. One means del t, this is calculation.
Got it, sir. Thank you.
Yes.
Hello.
Yes.
So, I didn't understand the point where when you said time shifting changes the phase spectrum.
Oh. What is the extra phase angle we got in time shifting, ma? When you are shifting, see the cursor, e power minus j omega t naught into x omega or not. If I take modulus of this one, it is simply mod x omega or not. If in e power j theta, what is extra theta, ma? This is looking like e power j theta. What is extra theta? Minus omega t naught. Means phase spectrum is a straight line. So it means it is changing phase spectrum or not. Tell me.
Yes, sir. Yes, sir. Got it.
Next step.
Yeah, that's it.
Yes. He has raised his hand and unmuted.